Okay, your objective for lesson 7 is I will interpret area models to form rectangular arrays. Okay, so we're going to draw a rectangular array that has an area of 18 square centimeters. So how could we figure out what the side lengths are if we know that the area is 18? Well, we know that we could use our tiles to make the array and see. If we just got out 18 tiles, we could make some different rectangles to see what the side lengths could be. We could also multiply side lengths and you get area, so we can think about what numbers we multiply together to make 18. So on your board, I want you to make a list of all of the multiplication facts that would give us 18. So what times what equals 18? List all of those on your board for me, and whenever you're ready to check those, I want you to push play. So I know that 1 times 18 and 18 times 1 gives me 18. 2 times 9 and 9 times 2 gives me 18. And 3 times 6 and 6 times 3 gives me 18. So we could take any of those equations, and those would be our side lengths, and we could draw a rectangular array with any of those. But we're just going to stick with one of these today. So you're going to need your ruler. So if you want to push pause and get that out. We're going to use our ruler, and we're going to be using the centimeter side to make a rectangular array that has 3 centimeters and 6 centimeters. So on your board, you're going to need to take your ruler, and I'm going to draw a line from the beginning all the way to 6, and I want you to do the same thing with yours. I'm going to move mine up a little bit. If you need to push pause to draw your line, make sure you're doing that. Okay, now that I have my bottom side length of 6, I'm going to turn my ruler to the side, and I'm going to have a side length of 3 centimeters. I can get my ruler to move because it's not moving for me. Okay, so I'm going to make my side length have 3 centimeters, just like that. And now, since I know that on a rectangle, opposite sides are equal, all I'm going to do now is take my ruler away, and I'm just going to finish drawing the top and the other side length to match what I have already drawn. So my rectangle is going to look like that, and yours is going to look similar to mine. We know that the area is 18. So since I drew this side to have 3 centimeters, I know that I'm going to need to have 3 rows. And since the other side is 6 centimeters, I know that I'm going to need to have 6 in each row. So I want you to complete your drawing of your rectangle so it is filled with squares that are centimeters. And then I want you to skip count each row to make sure that we have 18 as our area. So finish drawing that on your board and push play when you're ready to check it. Okay, so your rectangle looks similar to this, and if you were skip counting, you could have done 6, 12, 18. You could have also skip counted by 3s on the bottom and gotten to 18, so we know that this rectangle had an area of 18 square centimeters. Okay, turn your board so that it's the different way, so you are turning your rectangle to look like a different way. Does the rectangles, or do the rectangles still have the same areas? Yes, they still have the same areas, even though the side lengths switched places. We know that they have the same area because they both still have 18 square centimeters. So they both still have the same area even though they're turned. And that's kind of like what we did with the commutative property back in a few modules back, where we just turn our array. We still have the same area, it's just turned a different way. Okay, so the grid that you drew inside of your 3 centimeter by 6 centimeter rectangle shows a picture of all the tiles that make up an area. So this is what we drew in the beginning. Now we have an empty rectangle that just has the side lengths labeled. And this right here is called an area model, and you're going to hear that word in a few lessons that we do in the future with this module. So this right here is an area model. It doesn't have all of the unit squares drawn in it. It's just blank on the inside, but you do have the side links labeled, so you could still figure out what the area of this rectangle is without having all of the squares, because we know that all we would have to do is multiply 3 and 6, and that would give us an area of 18. So you're going to be seeing some area models in this lesson as well. Okay, so this right here is an area model because we don't see any squares drawn in it. All we see is the side links. So all we would have to do to find the area of this rectangle is multiply 18 and 1, and that would give us the area of 8 square centimeters. We figured that out by multiplying 18 and 1 together. Okay. So you have this template in your binder. So if you will take a look at this paper in your binder, and this is an area model. Right here, this rectangle is an area model, but we're going to use the squares around it to help us find what the side links are. So I noticed right here that on this side of the rectangle there are 1, 2, 3, 4 squares. So I know that the side length of this side is going to be 4. So I want you to go ahead and write that on your paper. I know that this up here has 2 squares, so I know that this side length is going to be 2. So all we would have to do is multiply 4 and 2 to figure out what the area of this rectangle is. So I want you to go ahead and do that. And I want you to write the area of the rectangle inside of this blank rectangle. And we're working with unit squares. So make sure whenever you write the area that you're putting unit squares down. Push play whenever you're ready to check your answer. Okay, so the area of this rectangle was 8 square units, and if we finished drawing all of the lines in the rectangle, we would have seen that there would have been 8 squares in that rectangle. Okay, we're going to be ready to move on to the problem set. If you will get that ready, and whenever you're ready, push play so we can work on it. Okay, so you've got a big whole area here, and you have different area models. As you can see with rectangle A, there are no lines drawn in it. We're just looking at the area model. So it says that you have to find and label the side links, and then multiply the side links to find the area, and you're going to use the bottom of the paper to write your multiplication equation that you use to find the area. I left A uncovered because I was going to do this one with you, and then I was going to let you work on all of the other rectangles yourself, and then we will check those together. So I can see right here that there are 1, 2, 3 squares. So this one right here is going to have a side length of 3. So I want you to go ahead and write that on your paper. I can see that up at the top it has 4 squares. So I want you to label this side length 4. Part of the directions said use a straight edge to draw a grid of equal size squares. Using your straight edge, that's just going to be your ruler. So we're going to take it and we're going to finish drawing the lines for the columns and the lines for the rows. If you don't want to use your ruler, you don't have to, but you do need to make sure that your lines are pretty straight and equal. So I want you to finish drawing in the squares for rectangle A. If you need to push pause, you can do that. Okay, so your rectangle would look like this, and now we're going to have to go down here to the bottom, and we're going to have to fill in the multiplication equation that we use to help us find the total area. And since one side length was 3 and the other side length was 4, that's where we get 3 times 4. And we know that 3 times 4 is equal to 12. So what you're going to need to do right now is you're going to need to work on all of these rectangles, filling in the squares just like we did for A, and labeling what the side lengths are. Once you have done that with all of the rectangles, you'll need to come down here on the bottom and you'll need to write down the multiplication equations that you used to help you find the total area of each rectangle. So whenever you are finished with all of your drawing and finding the side links and all of your multiplication equations, I want you to push play so you can check your answers with me.
Go back.
So we're going to start here at the top looking at this rectangle. It looked very similar to what mine looks like with all of the squares drawn inside of it. And I know that this side length was 2, and I know that this side length was 7. Okay, I'm going to move on to this small one right here. It would look like this. There's just 3 squares. This side length was 1, and this side length was 3. This rectangle down here at the bottom looked like this. And this side length at the top was 2, and this side length on the side was 4. This other rectangle right here looked like this. Is a pretty big one. The top side length of rectangle D was 4, and the side length of the rectangle was 7. This last rectangle for rectangle B, this side length was 5, and the top side length was 4. Okay, so down here at the bottom for rectangle B, I was looking for 5 times 4 equals 20. For rectangle C, you should have put 2 times 7 equals 14. Rectangle D, 7 times 4 is 28. Rectangle E, 1 times 3 is 3. And rectangle F should have been 4 times 2 equals 8. Okay, you need to be on the back side of the problem set. Number 2 says the area of Benjamin's bedroom floor is shown on the grid to the right. Each square equals 1 square foot. How many total square feet is Benjamin's floor? So I have mine covered up because A, B, and C tell you to do something. Okay, so the first thing that you need to do is label the side links. And notice that we're working with square feet and that each square is a square foot. So whenever you label your side links with a number, you need to make sure that you're putting feet with your number. After you label both side links, you need to use a straight edge to draw a grid of equal size squares within the rectangle. So you don't have to use a straight edge if you don't want to. Your straight edge would be your ruler. But you do need to finish drawing in that rectangle to complete it to show all of the squares. And then after you have done that, you need to find the total number of squares, which is like finding the area. And I want you to write that right underneath C. So once you have done all 3 of those things for A, B, and C, I want you to push play to check your answer. Okay, so the rectangle is going to look like this. This side length was 9 feet. And the other side length was going to be 11 feet. And then whenever you fill in all of the rest of the squares, it looks just like this one does. You see that they've got dots right here on theirs just because they were looking at the side lengths to figure out what the area was instead of counting every square inside of this one. So that was a good way to find the area. If that's what you did, then good job, because it takes a long time to count all of these squares. So the total number of squares is going to be 99 squares, and that's what you needed to put for C. Okay, moving on to number 3, it says Miss Young's art class needs to create a mural that covers exactly 35 square feet. Miss Young marks the area for the mural as shown on the grid. Each square equals 1 square foot. Okay, so did she mark the area correctly? So when you look at this right here, I want you to go ahead and label it just like I did. You don't have to put the dots, but I do want you to put the numbers, because you see right here that there are 6 going across the top and there's 7 going down. So I know that if I take 6 times 7, that would give me the area of what this mural is. So did she mark her area correctly? Well, we know that whenever we multiply the side links, that's going to help us find the area. So I want you to answer in a sentence if she marked hers correctly, and then I want you to explain your answer of why she did or why she didn't. Okay, so you didn't have to put 6 times 7 equals 42, but she marked hers with 42 square feet, so not 35. So she is not correct. So as long as your sentence had something to do with that, then it was correct. So moving on to number 4. Oh, goodness. Okay. Miss Barnes draws a rectangular array, and Mila skip counts by 4s, and George skips counts by 6s to find the total number of square units in the array. When they gave their answers, Miss Barnes says that they were both correct. Use pictures and numbers and words to explain how they both can be right. Okay, so what I want you to think before you draw anything is think about the side links. So if one person, Mila, is skip counting by 4, that tells me right there that one side length is going to be 4 because she can skip count by 4s. But if George is skip counting by 6s, that tells me that another side length could be 6. And we know that when we're working with side links that all we have to do is multiply those to find the area. So that tells me right there that one side length could be 4 and that one side length could be 6, and that's going to help you draw your rectangle. So whenever you draw your rectangle, make sure that you have all of the squares in the rectangle, and use words to explain how they both can be right, and use numbers to tell me how they both can be right. And whenever it says use numbers, I do want you to write down the equations that would help to find the area. Whenever you're ready to check your answer, you may push play. Okay, so it looks similar to this. It could have been turned the other way even, but this side has 4 and this side has 6. So both of them could have been right because she could have skip counted by 4 on all of the columns, and George could have skip counted by 6s in each row. Okay, so Mila could be right because there are 4 columns or rows depending on how you put it. And George could be right because there were 6 columns or 6 rows depending on how you drew your array. So I was looking for 4 times 6 and I was looking for 6 times 4 as your equations. So as long as your answers are along the same lines as mine are, as long as they're similar to what I put, then you're good to go. If you need to correct anything before you move on to B, I want you to go ahead and do that. So how many square units might Miss Barnes's array have had? And we know that if we multiply 4 and 6, that would have given us 24 square units. So we need to make sure that we put that down for B. Okay, I want you to go ahead and complete the exit slip. There is a number 1 and there is a number 2. Make sure you're answering all parts of the question before you bring it to me.